Hello everyone, I'm Sashwat and I'll be introducing you today's tutorials. So today we are trying to understand how humans deal with changing information in the world and still be able to function in such a world, and how we can let machines have this ability. Right? So this is the problem of lifelong learning or just learning in general. So we'll start with understanding what is the problem in the first place in learning lifelong. So the big issue is what we call distribution shifts. You learn on a part of data and then you are exposed to another part of data. You need to be able to integrate information across time, for example. And so this is something machines find hard. And so we'll go through that. So first we'll introduce the idea of distribution shift, and then through the tutorials you will see solutions proposed such that machine learning systems can do well on problems which have distribution shifts. So yeah, they don't generalize on new data due to distribution shift. So there are multiple types of distribution shifts. Let's start with an example. Let's say you're the United Nations and you want to build a summary of when is the best month in the year to plant tomatoes, and you want to do it based on the latitudes, right? So let's say you start by training your model only on the northern hemisphere. Southern hemisphere has latitudes going from 0 at the equator to 90 at the North Pole. It's the same for the Southern Hemisphere. It goes from 0 and then 90 at the South Pole. Let's say you train your system to output the best month given a particular latitude, and now you test that system on the Southern Hemisphere. You did not train on that. Most probably, your system will fail. Well, it will fail because the input-output mapping for the Southern Hemisphere is exactly, let's say, 6 months delayed, right? Because the seasons are exactly the opposite. When it's summer, it's winter in the Southern Hemisphere. So this will not work. The model you train will not work outside the hemisphere it's trained on. This we refer to as a covariate shift in the distribution because the input has changed, the input distribution changed, but the function model computes stays the same. It's basically linking the distance from the equator, which predicts certain things like seasons and also the kind of climate you have and stuff like that. That kind of stays constant in north and south, right? And so that mapping to the best month stays preserved. Is just that because the input has changed, the only thing you need to do is you basically need to say output plus 6, right? And then that would be the true output. So the model stays the same. It's just that because the input distribution has changed, you need to change the outputs correspondingly. But the function itself stays the same. That's a covariate shift. You also have something called a concept shift, where the mapping itself changes. So the function that the model is implementing has to completely change. So this would be something like, we have climate change. This means seasons are changing. Microclimates are also changing all over the planet. So the mapping between latitude and a particular best one to plant tomatoes might not be preserved. For example, now for this latitude, it's March, right? And now there's no way your model will work, even if you just add like some distribution shifts in the input or the output to try and match it given the same function, right? So you have to do something to the function. You have to make sure the function adapts to this changing input output mapping. So two types of changes, covariate and concept. So in the tutorial task, what we'll do is we'll basically study these two changes. So here we're going to look at a different problem. So we will create a synthetic data set about fruit prices, and then on this data set you can test out different distribution shifts and what problems that creates for simple models. So what we'll do is we'll cook up a function which represents the price of fruit at a grocery store over the course of a year. And so let's say mid-year is where the price is the lowest, so June 26th, right? And then as you go to the other months of the year away from June, the price increases. And then you have some local fluctuations. This might be due to, let's say, the fruit is on the shelf, needs to get discounted, so the price drops, and then a new shipment comes, price goes up, right? Just a simulated problem, but this can already help us demonstrate all these different types of distribution shifts. So what we'll do is we will train a simple multi-layer perceptron, which is a small neural network, to predict the price by day. So given a day in the year, you have to tell us the price, right? And then we will explore covariate and concept shifts in this task. So that's your task for today.